Okay, this is lesson 4.5, and it's arithmetic sequences. Arithmetic sequences. Those of you that had Math 7 last year, you should be familiar with sequences. How about 6th grade? Did you guys do sequences at all last year? Nothing at all? Okay. Well, sequence is simply a series of numbers. An analogy would be the picture there. This is photography, right, of the event, and so you're clicking like, I don't know how quick the shutter is going, but you're catching, every, I don't know, hundredth of a second or whatever of this motorcycle jump, and the guy's doing a backflip, and you can see the sequence of events, right? He starts off here, use yellow, going off the ramp, and now he's into his backflip. Now he's getting rotated around. In the next sequence, you can see he's upside down, starting to come around. Thankfully, he's still with his bike. Otherwise, that would be nasty. He's coming around even more and more and more, getting ready to land it, and there he lands it, right? And so the picture is representative of a sequence. All right, we're going to talk about arithmetic sequences. Your book also talks about geometric sequences. There are two different kinds. There are actually more than that. The two main kinds are an arithmetic sequence and a geometric sequence. We'll talk today about arithmetic sequences, actually today and tomorrow. All right, what is a sequence? It's a set of numbers ordered in a distinguishable pattern. It's a set of numbers ordered in a distinguishable pattern. So I have an example sequence below. The first number of the sequence is 1, and the second is 4. The third is 7. The fourth is 11. And most people can figure out what the next number would be. I don't want you to say anything out loud. But the first one is 4, first one is 1, second is 4. Ooh, that's a bad sequence. What in the world happened there? Okay, take your black, and we got to change this thing. First edition notes that you guys have, that should be a 10. All right, now we've got a real sequence. All right, so we've got 1, and then a 4, and then a 7, and then a 10. Therefore, the next number would be a 13. Correct. And the number after that would be a 16, and then a 19, etc., etc. And we're able to distinguish the pattern and figure that out. All right, those are arithmetic sequences. I'll show you why we'll call it an arithmetic sequence in a minute. Before we get there, though, I want to talk about this. This, in particular, is an infinite sequence. Infinite. I-N-F-I-N-I-T-E, an infinite sequence. Anybody know what it means to be an infinite sequence, Edward? It goes on forever. So when does it end? Never. Ever, ever. I guess when the Lord Jesus Christ comes back, it will end. All right. Until then, it doesn't end. It goes on forever. So you always go 3 more, and 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 there's always 3 more. 3 more. When does it stop? In infinity, if you can get there. I guess Buzz and the gang can figure that one out, but it's an infinite sequence, right? It keeps going on forever. And how do you know that? It's because of those 3 dots in the end, and I think we did. See, I have to keep my courses straight. I know I talked about this in Algebra 1. Have we talked about the 3 dots and what they're called? Emily? Close. Ellipses, right. Not an eclipse of the sun or the moon, but an ellipse like elliptical. All right, so they are called ellipses. E-L-L-I-P-S-E-S. 3 ellipses, which are simply what? Like dots or periods, are used to indicate an infinite sequence. And remember this, whenever you're going to use three dots, you're always supposed to show at least three in the pattern before you use the three dots. Same thing with numbers and all that stuff. So we've got an infinite sequence. Now, what if something were not infinite? What would it then be if it's not an infinite sequence? Christina? How do you say uninfinite? That's true. Colby? How do you say not infinite? Because uninfinite, unfortunately, isn't a word. So how do we say not infinite? Luke? Definite's a good word, but it's not the technical word. It begins with an F. Omar? Okay, he knows it, but the pronunciation is finite. So you have infinite and finite. Take the IN away, and FINIT is usually pronounced finite. Finite means it has an ending. Infinite goes on forever. So your sequences will be either infinite or finite. Finite has a distinct end. You won't have three ellipses on the end. An infinite sequence, you'll see the three ellipses. Christina. Kristen, sorry. If it's finite, it ends. There could be blanks, but I mean, but they would have an ending number. It wouldn't have the three ellipses at the end. The blanks would be there to see if you know how to fill in the pattern. So that's possible, yes. Okay. All right, let's write a few more things here. See, each number of a sequence is called a term. Each number of a sequence is called a term. So you have the first term, the second term, the third term, the fourth term. So if we go back up to A in our example, number 1 is the first term, the 4 is the second term, the 7 is the third term, the 10 is the fourth term. We didn't show the fifth term, but we said it was 13. We didn't show the sixth term, but we said it was 16. We didn't, et cetera, on and on you go. So each number of the sequence is called a term. And each term is identified by a subscript. By a subscript. And the subscript simply tells you which term it is. So this isn't hard. If you see, for example, B sub 2, usually say sub for subscript, B sub 2. We would want what term? What would make sense? B sub 2 would make sense if it's the what numbered term? Is B sub 2 going to be the first term? Will B sub 2 be the second term? Yeah, it's the second term. That's all it is. Second term. B sub 2 says, what's the second term? So look at the B sequence, and we all say the second term is an 8. All right, there you go. B sub 2 is 8. Not hard at all. B sub 2 says I want the second term of the B sequence. Give me the second term of the B sequence. Christina. So let's go back to the sequence. Remember, the 3 is the first term. The 8 is the second term. I want the second term, B sub 2. Give me the second term of the B sequence. So Christina, do B sub 3 for me. What is the third term of the B sequence? It is, correct. They go in order. First term is the first one listed. Second term is the second one listed. Third one is the third term listed. So somebody raise your hand and tell me B sub 5. Julia? And hopefully you agree with Julia. Even though it's not shown, we know it's a 23, right? We're following the pattern. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5, 23. The fifth term's got to be 23. Sixth term's got to be, sixth term is 28, right? etc., etc., etc. So we're going to use a subscript. All right, so why don't you guys fill in R sub 2, R sub 3, and R sub 5. R sub 2, R sub 3, and R sub 5. R. All right, so Raf's question was, does the sequence always have to start with a positive number? No, it doesn't have to. All right, so R sub 2. Nathan, give me R sub 2. Hopefully you agree it's -1. Hayden, give me R sub 3. -7, and hopefully you agree it's -7. Nia, give me R sub 5. Okay. Brendan? Let's see. We're going 6 lower each time, right? So we're adding a -6. -7 and -6 is -13. -13 and -6, as Brendan says, is -19, right? -19 is the 5th time. You could write them out, right? You could come here and write -13, -19, ... and there you go. There's your 5th term. Now, notice in the B sequence, I have it in braces. And notice in the R sequence, the pirates robbed the braces. R. All right. Sometimes you'll see them in braces and sometimes you won't, and that's why I did it both ways. You just got to understand that sometimes they'll be in braces and sometimes not, and that's okay. It's still sequence and things. The first one's always the first one listed, etc., etc., etc. All right, and pirates won't always rob the braces. All right, maybe they were gold braces. Actually, they robbed the teeth because they're gold teeth. Okay, so number 2. Here's how you distinguish whether a sequence is indeed an arithmetic sequence. An arithmetic sequence is when each term is a constant amount from the previous term. Now, for those of you that might struggle with the word constant, above it I'll put a parentheses. And if you want, instead of the word constant, you can put the words the same. An arithmetic sequence is when each term is the same amount from the previous term. This amount is called the common difference. The common difference. And it's signified by lowercase d. So we'll call the common difference d. So Chloe, let me do one thing here and then I'll get your question. So look back up at our original example there in A. What would the common difference be? Go ahead and say it on 3. 1, 2, 3. Yeah, on 3. 1, 2, 3. Yeah, on 3. 1, 2. No, it's 3, right? Common difference is 3. So the value of D would be 3. Chloe, question? Constant is the best word there. But I'm more concerned that you understand that it's the same amount and that it's called a common difference. Okay. All right, let's take a look at our example here. We got sequence Q, 7, 18, 29, 40, 51. And therefore, those of you that numbers come easily to you, you look at that and you can quickly come up with the value of D is 11, right? That's the common difference. Ooh, don't know how I got in purple there. Because again, if you look at the gaps, that's 11, and that's 11, and that's 11, and that's 11, and every one is 11 more than the previous, right? Common difference. Again, we have an infinite sequence. This one's going on forever and ever. All right. So this is all background. Now let's get to some nitty gritty. Go higher for you guys. Okay, so now we're going to get to what's called the recursive formula. All right, that's a big word, I know, recursive. You guys write in cursive. Well, put a RE in front, and it's recursive. The recursive formula. There are actually two different kinds of formulas. If you turn the page of your notes, you're going to see that we'll talk about later on the explicit formula. So there's a recursive formula and there's an explicit formula. And we got to keep them straight. Whoever said you can't study for math was a moron. I mean, an absolute moron. Of course you need to study for math. On Sunday morning, I happened to walk through a room and a parent was talking to one of our other math teachers, and they were talking about the aspect of, well, can you or can't you study for math? And I happened to be walking by, and I just, did the rolling of my eyes, To be honest with you, I thought about this. I never thought about it before. I think you need to study for math more than any other subject. I'm dead serious. Look, what is a history test? Usually what, 20 things? 70? All right. But they're just things you memorize. Memorize a list of 10, boom, you got it. Memorize another list of 5. And I'm not saying you shouldn't study for history, and I'm not saying you shouldn't study for English, and I'm not saying you shouldn't study for science, but think you don't have to study for math? What, are you kidding me? I mean, how many things will we learn in this chapter alone? I'm guessing in the 60s or 70s of different concepts we would have learned by the time this chapter is over. And so, of course you got to study. Well, we've got a recursive formula and explicit formula. We've got to keep them straight. Okay, what's the value of a recursive formula? It's used to find a term when you know the previous term. It's used to find a term when you know the previous term. Now, what you guys have to understand is the format of it. So, if you guys will watch carefully, I'll try to explain everything. The A there means we're talking about sequence A. And usually the subscript tells you which term. Well, n is a variable. If we're talking about this, you shouldn't write anything. You should just be looking right now, guys. If we're talking about the 7th term, it would be a sub 7. If we were talking about the 50th term, it would be a sub 50. If we're talking about the 3rd term, it would be a sub 3. So A tells us the A sequence. The subscript tells us which term we're talking about. So we try to get you guys to understand. So don't write this, just look. So let's suppose we're talking about the 14th term. So it wouldn't be a sub n, it would be a sub 14. Now the next thing we come to is a sub n minus 1. Well, in case you didn't figure it out, in this sequence, n is 14. So we're talking about the 14th term. Therefore, what does a sub n minus 1 mean? Does that make sense to anybody? If n is 14, a sub n minus 1 must be what, Ashley? A sub 13, exactly. And what does a sub 13 represent? Colby? Perfect. Exactly, right? The 13th term. Remember, the recursive formula allows you to find a term if you know the previous term. So we're looking for the 14th term. If we know the 13th term, all we got to do is add to it the common difference. Isn't that what we did in our heads a minute ago? Watch, let me go back. Way back up here, when I asked you for the next term, which would have been the first, second, third, fourth. When I asked you for the fifth term, didn't you go to the fourth term and add the common difference to it? Right? You said 10 plus 3 is 13. The fifth term is 13. Exactly. So this is just the math of that. It's just the math of that. Okay, so don't let this scare you. Just understand what all the terms are, and it becomes easy. Okay, so here we've got an example. Here's a sequence right here, sequence H. And it's -4. Oh, there you go, Raph. Look at that one starting negative, right? -4, 2, 8, 14, 20, 26, dots, dots, dots. All right, so we got a sequence. And we want to find the seventh term. 1, 2, 3, 4, 5, and there are 6 listed there. So again, technically to use the formula, the seventh term, oops, that should have been blue. The seventh term, you guys can do this now. And I'm just for ease sake going to clarify, will equal the sixth term, right? Isn't that 7 minus 1, right? Previous term. And somebody tell me what the value of D is for this one. Luke? And hopefully you agree the value of D is 6. So again, I made it a little longer by sticking that 6 in there, but I just want to make sure you guys understood. And so help me out. Christina, what is the value of H sub 6? What's the value? So somebody translate that. What does H sub 6 mean? Translate that to what we're doing there. Nia? It's the 6th number in the sequence. So Christina, what's the 6th number in the sequence? Don't be afraid to count. That's what I'd have to do to figure it out. What's the 6th number of this sequence? And you can say I'm not sure if you're not sure. Yeah, it is 26. Look, this is H sub 1, the first. This is H sub 2, the second. That's H sub 3, the third. This is the fourth. This is the fifth. And surely 26 is the sixth, right? So we really end up, and again, look, in your mind, this is a breeze, right? We'd have been done 5 minutes ago if we were just doing it in our head. But there's a reason for learning the formulas, and it'll come out later on. So we know then that the 7th term has to be 32. Again, though, the restriction of the recursive formula is it really only helps you if you know the previous term. That's the only way it helps you. So unless you know the previous term, the recursive formula isn't very valuable. What if I asked you, what is the 345th term? Well, we got to find the 344th term before we can find the 345th term. So in that respect, the recursive formula has restrictions. All right, but there is value to it, and that's what we're going to try to learn. So let's see now if we can write the specific recursive formula for the D sequence that is 0, 4, 8, 12, etc., etc. Okay, don't let that question cause you a lot of alarm. It's really a pretty easy situation. All we need is the value of D. That's all we've got to do to write a specific recursive formula. So here's what I mean. Everything here is a variable, correct? Everything in the blue box, it's all variables. So this is the recursive formula for any arithmetic sequence, any one at all. Let's make the recursive formula for this specific arithmetic sequence. And the only difference is we simply need to find the value of D. All right. Well, that's not hard. You guys at this point should be able to look at it. And you're going to tell me the value of D is 4. Okay. Therefore, all I do then now is take my general formula, and I'm going to rewrite it just for clarity's sake. And where the D is, I stick in the value of the D. That's it. That is our specific recursive formula for that sequence. It just simply has the value of D included. Okay, not a whole lot there, but that is what that involves. So if they ask you to write the recursive formula, you have to know what a recursive formula is, and then you have to supply the D. Any questions so far? So what have we talked about so far? A sequence is a distinguishable pattern. 3 ellipses is its infinite. Remember, the subscript tells you what numbered term that is. A B sub 2 is the second term. A Q sub 11 is the 11th term of the Q sequence. Here's a recursive formula for an arithmetic sequence. What's distinguishable about an arithmetic sequence has a common difference. The amount between each number is the same. All right, let's go to the second page. So there's that recursive formula again. It says write the first 5 terms if A sub 1 is 7 and D equals 3. And to be honest with you, these are pretty simplistic. If you understand it's an arithmetic sequence and you know that D is 3, what's the second number going to be? What's the second number? 10. Right? So look, A sub 1 said, hey, the first number is 7, so the second is 10, the third is, the fourth is, and the fifth is, and there are the first 5 terms of that sequence. Now we could use the formula as well, but really that's so easy to do in your head. You know, if you were going to use the formula, here's what you would do. Don't write this. You would say, okay, the second term is the first term plus the common difference. Oops, wait, 3. And therefore, the second term is a 10. And the third term is the second term plus the common difference, and therefore it's 13. And the fourth term is the third term plus the common difference, and it's 16. And the fifth term is the 16 plus the common difference, and it's 19. But it's so easy to do it in your head, isn't it? I mean, once you understand what that common difference is, we can just say 7, 10, 13, 16, 19. So same situation here, write the first 5 terms of the sequence. Do you guys have homework at the bottom of yours? Right? That's what I'm thinking, so I don't know why that's there. My notes are a little bit different. Okay, so good. I didn't think you did, and you shouldn't have. Man, I'm that. What in the world happened? That didn't even copy the whole page. Okay, I'll fix that in a minute. Okay, so write the first 5 terms. If A sub 1 equals 12, be careful there. Go ahead and complete that. First term is 12. Write the second, third, fourth, and fifth of D. Chloe. Huh? Is it right up there? Okay. I got it now. So that's where it is. Okay. All right. I'm with you. Oh, excuse me. Okay. So go ahead and write. Somebody go ahead and finish off those first 5 terms. You got 12. Give the second, third, fourth, and fifth. If you can't do it in your head, do the formula. If you can't do it in your head, do the formula. Hayden, what do you got? All right, and Hayden is correct, and I hope you agree. 12, 7, 2, negative 3, negative 8. Makes sense? Okay, this is, I don't want to get you confused with sequences. We'll talk about explicit tomorrow, and to do that, that's why I broke it up into 2 parts, and that's why your homework's listed there. So we'll do some arithmetic stuff today with recursive and sequences, and then work on explicit tomorrow.